So sometimes when we make a solution, we actually don't start from a solid. Sometimes we start with a really concentrated liquid. You may have seen, like at the grocery store, sometimes you can get like little drops that you can put in water to make it taste like fruit punch or pink lemonade. And so what we're basically doing is taking a super concentrated solution, adding a ton of water to it and making it more dilute. And this is showing you in a picture how that would work. That the first thing that we would do is we would take out a very specific amount of a stock solution. This would be the stock solution is concentrated. If you look at the picture here, right, it's really a darker blue. And then you can see I take out a specific amount and I add it to another volumetric flask. And then I add a solvent, usually water, right? I add that to the mark, again, to dilute the solution. And the formula that we use for figuring out how much solute that I want to take out is M1V1 equals M2V2. So you can think of it just like we did with the gas laws, that M1V1 would be like new conditions and M2V2 will be old conditions, or vice versa. Or we can think of this as being concentrated and this side being the more dilute. And it doesn't matter, you just need to make sure that the dilute are on one side and the concentrated are on the other side. And in terms of units, obviously molarity needs to be the same unit, but you see that it's V here for volume. The volume unit doesn't matter, but it needs to be the same on both sides so that they will cancel. So just the same rules that we've been using this whole year about the units canceling are still going to apply. So this question says, suppose a laboratory procedure calls for 5 liters of a 1.5 molar KCl solution. So that is the dilute solution. The question says, how should we prepare the solution from a 12 molar stock solution? So I need to know how much of the stock solution I'm going to need to remove. How I do that is using the dilution formula, M1V1 equals M2V2. So the dilute numbers that I'm going to use, I know that I'm going to need to have a 1.50 molarity solution, and I know that volume is going to be 5.00 liters. I know that the stock solution that I'm going to use is 12.0 molarity, but I don't know how much of that I'm going to need to remove. I don't know my second volume. So I just, using algebra, divide both sides by 12.0 molarity. And I notice that the molarity units cancel out on the left-hand side. The only unit that is left is liters. So my calculations tell me that I will need 0.625 liters of the concentrated solution. I'll need to, right, take this 0.625 liters of the concentrated solution, put it in a volumetric flask, and then add enough water to make 5 liters of solution. This is another problem here. To what volume, so I'm going to be solving for one of the volume numbers, should you dilute a 0.1 liters of a 15 molar NaOH solution to obtain 1.0 molar NaOH? So I know that, for example, these two are my concentrated ones. This is the dilute one, and I want to know what will be the volume of the dilute solution. So M1V1 equals M2V2. My strong molarity is 15 molar. And what volume will I have of that? 0.100 liters. My new molarity is going to be 1.0 molar, and I don't know my new volume. Now I multiply these two numbers together, divide by 1.0 molarity. Of course, dividing by 1 doesn't change the numerical value. So it's really just 15 times 0.1, which is going to be 1.50 liters. That is what my new solution will need to be diluted to in order to have the 1.0 molarity. And then the very last thing that I want to talk about is when we do this in real life, right? We looked at this picture here, and you see that we take this solvent, usually water, and we add it to whatever is this really concentrated solution. And that is true. That's how we make these, except if what we are diluting is an acid. When we dilute an acid, it is a very exothermic process. So if I were to take, so these are the wrong things to do. This is the right thing to do. If I were to take the acid and just add a little bit of water at a time, I would be diluting all of the acid all at once. So that would release, exothermic, it would release a lot of energy, a lot of heat. And you can actually make it so that the solution starts to boil. And now you have boiling acid, steaming acid. That's not a good situation. So what you do instead is you actually have the water down here and you add the acid. And so that's what we are taught to memorize, right? Adding acid, that we always add the acid. Because in that case, we're only diluting a very small bit of acid at each time. And when we do that, it's releasing heat, but it's releasing a smaller amount of heat, and we can let that sort of dissipate before we keep adding the rest of the acid in. So we have one practice question before you start on your practice homework problems, and that is, what is the molarity of a solution in which 100 milliliters of 1 molar KCl is diluted to 1 liter? So M1V1 equals M2V2. My first molarity is 1.0. My first volume is 100.0 milliliters. The question is asking, what's my new molarity? And the diluted solution is going to be 1.0 liters. Now, notice this unit is milliliters and this unit is liters, so they will not cancel the way that I have it written. And it actually doesn't matter if I convert milliliters to liters or vice versa. So let's convert this to liters, 100.0 milliliters. Well, there's 1 liter for every 1,000 milliliters. So I divide that number by 1,000 and I get 1.0 molarity times 0.10 liters, 0, that has 4 significant figures, equals my new molarity times 1.0 liters. And then, of course, dividing by 1 doesn't do anything, but I need to show that my units are canceling out, and 1 times 0.1 divided by 1 will be 0.1. I only have, 2 significant figures, so 0.10 molarity will be the new molarity after I dilute it. So my right answer there is A.